In 1940, Britain rushed to build an anti-tank gun, but this one had a strange problem. Before it could even fire, the crew sometimes had to tip the entire weapon over. Not because it was broken, because that was how it was designed. The weapon was called the Smith gun. It was built fast, built cheap, and meant for the home guard defending Britain from invasion. Two oversized wheels, a circular steel baseplate. Oh, and a deployment method that looked more like moving a wheelbarrow than operating artillery. But once the gun was in position, it could fire the same armor-piercing ammunition used by standard British anti-tank weapons. So, why did Britain issue thousands of these strange machines? And why did crews struggle so much just to deploy them? To understand that, we need to look at the desperate engineering decisions Britain made in 1940. In 1940, Britain feared immediate armored invasion. The German armored divisions had collapsed European defenses rapidly. British planners expected similar armored attacks domestically. Home guard formations lacked effective anti-tank weapons. Regular army guns remained reserved for frontline units. Emergency defensive weapons became urgent national priority. Government committees demanded extremely simple artillery systems. Factories required minimal retooling for rapid production. Manufacturing complexity had to remain extremely low. The civilian engineering firms submitted emergency weapon proposals. One proposal originated from Major William H. Smith. Smith collaborated with Trianco Engineering Workshops. Trianco normally manufactured domestic heating boilers. Their facilities contained extensive steel welding capability. Government authorities approved rapid prototype construction. The weapon required standard 2-pounder ammunition. Existing ammunition simplified wartime logistics immediately. Surplus artillery barrels provided immediate, usable components. Engineers avoided developing new ballistic systems. Design emphasis focused entirely on manufacturing simplicity. Machining operations were deliberately minimized. Extensive welding replaced complex mechanical assemblies. Recoil systems were intentionally eliminated completely. Engineers expected ground contact to absorb recoil forces. This decision simplified structural construction significantly. However, unusual deployment procedures became unavoidable. The resulting weapon became known as the Smith gun. Its carriage differed sharply from conventional artillery. Two oversized steel wheels supported the structure. Wheel diameter exceeded standard field artillery proportions. A rigid axle connected both wheel hubs. The axle attached above a circular steel baseplate. The baseplate supported the entire firing structure. The barrel pivot mounted centrally on the plate. Transport orientation differed from firing orientation. During movement, the barrel pointed vertically upward. Crew pushed the weapon using wheel leverage. Handling resembled maneuvering a heavy industrial wheelbarrow. Weight distribution remained awkward during transport. Total weapon mass approached roughly 270 kilograms. Several operators were required for stable movement. Single operators struggled maintaining balance control. Deployment required rotating the weapon forward. Crew tipped the carriage onto the baseplate. This motion positioned the barrel horizontally. The baseplate then contacted the ground surface. Correct contact ensured proper firing stability. Improper tipping produced immediate alignment problems. Barrel impact with ground occasionally occurred. Training manuals stressed careful tipping coordination. Operators practiced controlled movement repeatedly. Deployment remained slower than conventional anti-tank guns. Hard pavement amplified recoil vibration considerably. Soft earth absorbed recoil forces more effectively. Initial prototypes entered testing during late 1940. Trials occurred at improvised military firing ranges. Home Guard volunteers served as evaluation crews. These observers recorded extensive handling observations. The breech employed a sliding block mechanism. Mechanical complexity remained extremely limited. Few moving components simplified maintenance procedures. However, breech sealing occasionally weakened. Gas leakage appeared after repeated firing cycles. Maintenance instructions required frequent inspection. Barrel length matched standard 2-pounder specifications. Rifling twists stabilized armor-piercing projectiles effectively. A muzzle velocity matched regular anti-tank guns. Armor penetration depended on ammunition selection. Solid armor-piercing rounds formed primary supply. Penetration approached roughly 40 millimeters. Effective combat distance remained below 500 meters. Accuracy depended strongly on baseplate alignment. Minor ground shift altered aiming accuracy. Traverse capability remained extremely limited. Crews often repositioned the entire weapon. Each reposition repeated the tipping procedure again. Physical strain increased during training drills. The weapon lacked optical aiming devices. Simple iron sights provided basic alignment reference. Elevation adjustments remained coarse and limited. Range estimation depended largely on operator judgment. Training programs emphasized short-range ambush tactics. Home guard doctrine favored concealed roadblock positions. Smith guns frequently guarded narrow village approaches. Crews concealed weapons behind barricades or hedges. Sandbags often surrounded the baseplate perimeter. Recoil occasionally shifted the weapon slightly. Wheel oscillation appeared after several firings. Engineers reinforced axle brackets during production. Additional steel gussets increased structural strength. Material usage rose slightly after modification. Government procurement officers monitored steel allocation carefully. Industrial shortages remained constant during wartime production. Trianko engineers argued the weapon remained economical. Authorities approved expanded production quantities. Factory welders began large-scale fabrication operations. Workers previously assembling furnaces joined production lines. Manufacturing tolerances remained intentionally broad. Surface finishing rarely exceeded corrosion protection coating. Standard British service green covered exterior metal surfaces. Serial numbers were stamped onto breech housings. And documentation followed simplified wartime ordnance procedures. Each gun shipped with minimal instruction manuals. Manuals emphasized safe deployment procedures clearly. Illustrations demonstrated correct tipping angles. Training instructors supervised home guard instruction sessions. Crews practiced loading and firing sequences repeatedly. Ammunition arrived inside wooden ordnance crates. Crates matched standard British ammunition packaging. Supply quantities varied between regional depots. Many units possessed limited ammunition reserves. Practice firing occurred rarely after initial training. Operational familiarity therefore varied between crews. Some volunteers struggled with loading sequence timing. Delayed firing readiness appeared during exercises. Instruction manuals were revised after field feedback. Wheel locking instructions received clearer explanation. Additional diagrams illustrated safer operator posture. Engineering offices collected operational experience reports. Reports repeatedly mentioned awkward deployment effort. Crew fatigue appeared during prolonged maneuver training. Several minor injuries occurred during tipping operations. Medical logs documented occasional crushed fingers. Ordnance committees reviewed safety concerns periodically. Alternative carriage concepts received brief examination. Redesign proposals threatened production interruption. Officials retained the original configuration. Urgency outweighed ergonomic improvements. Trianko continued deliveries through 1941 production cycles. Output eventually reached several thousand guns. Distribution prioritized coastal defense regions first. Areas fearing airborne invasion received early allocation. Rural battalions stored guns inside agricultural buildings. Barn environments sometimes produced corrosion problems. Maintenance routines required periodic lubrication checks. Breech assemblies required cleaning after firing. Spare parts availability remained limited. Ordnance inspectors noted inconsistent reliability. Despite limitations, the weapon remained operational. Crews valued possessing anti-tank capability. The weapon provided psychological reassurance. Camouflaged guns resembled agricultural machinery occasionally. This resemblance sometimes aided concealment. However, mobility limitations remained severe. Rapid relocation proved extremely difficult. Turning the gun required considerable physical effort. Wheel leverage offered limited maneuvering advantage. Operators frequently became exhausted during drills. Some units constructed wooden deployment ramps. Ramps simplified tipping within prepared defenses. Sandbag revetments stabilized baseplate edges. Drainage trenches prevented water accumulation beneath plates. Wet soil occasionally reduced firing stability. Engineering guidance recommended compacted ground surfaces. Field conditions rarely allowed such preparation. Many weapons fired directly from natural terrain. Stability varied considerably between locations. Some guns jumped noticeably after discharge. Others remained relatively steady during firing. Operational inconsistency complicated standardized training. Ordnance evaluators continued collecting performance reports. Data accumulated throughout 1941 operational service. Comparisons with regular anti-tank guns revealed limitations. However, manufacturing simplicity remained unmatched. Unit production costs stayed extremely low. Material requirements remained modest overall. Factories required minimal specialized machinery. Trianko workers adapted rapidly to wartime demand. Government planners briefly considered foreign distribution. Allied procurement authorities preferred conventional artillery. Export discussions ended without agreement. Smith guns remained domestic defensive weapons. Home guard formations integrated them into roadblock systems. Photographs documented volunteers posing beside the weapon. Public information pamphlets referenced defensive readiness. Strategic conditions gradually shifted after 1942. Immediate invasion threat declined significantly. Many Smith guns entered long-term storage depots. Maintenance inspections occurred periodically afterward. Several examples later transferred into museum collections. Historians examined the weapon extensively afterward. Studies emphasized industrial improvisation under invasion threat. Engineering assessments highlighted carriage handling difficulties. Mechanical leverage during tipping remained inefficient. Operator posture during deployment proved awkward. Modern analysts classify the weapon as emergency artillery. Every structural decision reflected wartime urgency. A manufacturing convenience dominated design priorities consistently. Extensive correspondence documented procurement debate. Officials repeatedly questioned operational practicality. Despite criticism, the weapon reached widespread distribution. Smith gun production demonstrated rapid wartime industrial adaptation.